Hello guys, this is Prime Concept and I'm back again. We have another problem here under electricity, and the question says a battery of EMF 2 volts and internal resistance zero point 0.5 ohms is connected across an external resistance of 9.5 ohms. Find the power dissipated in the 9.5 ohms. Now you would notice in this question that we have two resistance in this question. One of them is called internal resistance, and the other one is called external resistance. So, what is actually internal resistance and what is actually an external resistance? It's very simple. I explained in my earlier videos that when you buy a battery from the market, and then the battery they told you, let's say they say the voltage of that battery is 2 volts, and you measure, you are expected to get 2 volts. Now, in a real case, in a practical case, when you buy a battery of 2 volts and you measure it, usually you don't get 2 volts. You may get something around 1.998 volts, 1.96, 1.95 volts. So you won't get exactly 2 volts. The reason is because every battery has what you call an internal resistance. So every battery has a resistance, and that internal resistance would reduce whenever you connect it to a voltmeter to measure that voltage. That internal resistance would reduce the value of that voltage, and that is why in a real case is not always the exact thing. So what you should basically understand is that the internal resistance is the resistance inside the battery, the resistance of the battery itself, while the external resistance is the one that is connected out, right? That is, say, your load, your bulb, or whatever. Now let's draw the circuit diagram that would help us solve this problem. So we have this. So this is our external resistance. I will denote our external like this, which is 9.5 ohms connected to my battery. So this is my battery. My battery is 2 volts, right? And then the battery has an internal resistance. So I'm going to draw the internal resistance differently, but I'll use this second symbol for resistance to denote that. So this is going to represent my internal resistance, which is actually zero point 0.5 ohms. So this is the current that is flowing through this circuit. The question is for us to find the power in our external resistance. Before you can find the power in the external resistance, you need to know the current in that resistance, right? So that you can do it. Now, if you look at this circuit, you simply notice that we have two resistors, and these two resistors are connected in series. So watch it very carefully, you will see it's a continuous line. So they are connected in series. So one of the first things I want to do here is to get the equivalent resistance. Now, since both of them are connected in series, remind me, how do we get the equivalent resistance for this? It's very simple, you are correct. We simply add them up. So my equivalent resistance is going to be the summation of both of them. So it's going to be 9.5 plus 0.5. So this is my equivalent resistance, which is going to simply give me 10 ohms. So my equivalent resistance is 10 ohms. Now, if you are to redraw this circuit, it's going to be a circuit that contains only one resistor, right? Now, let me redraw the circuit. I'll be rubbing this to redraw it. So if I'm to redraw it, I would simply have this, and this is now going to be 10 ohms, a circuit containing only one resistor. So with this, we can get current using Ohm's law. So according to Ohm's law, V is equal to IR. Then if I make I the subject, I would have that I is going to be V divided by R. And what is my voltage? My V is 12 divided by my R now, which is 10. So I have 1.2 amp. So for me to get my power, simple. You recall one of the three formulas for power I gave you. So I'm going to use one of them, which is P equals I, okay, I squared R, since I'm trying to get the power across my 9.5 ohms, right? So I'll be using this times that resistance. So I have my current 1.2 squared times my resistance, which is 9.5, not 10. They say we should get the power dissipated in our 9.5 ohms. So that's what I will now use this time around. So I have 9.5 ohms. So if we multiply this very quickly, I have 1.2 square. So if we multiply this, we'll get our power to be 13.68 watts. So this is my answer. So this is the power that will be dissipated in 9.5 ohms. All right. I believe that this concept is very clear to you. Thanks for watching my video. Do subscribe to my channel. Share the video with your friends so that they can also benefit. Remember, this is Prime Concepts, unraveling the concept.